Hi guys, let us today understand what is power factor. So to understand the power factor, we need to go back to our circuit once again. That resistive circuit. So let us draw the circuit once again. Let's say we have a resistive circuit. This is the resistance of this circuit, and this is the voltage source, and this is an alternating current voltage source V, and this is R. Let's say the supplied voltage is 10 volt, and the resistance is equal to 2 ohm. Fine. So what is the current flowing? I equal to V by R. So here it is 10 by 2 equal to 5 ampere, right? So current flowing through this equal to 5 ampere. Now if I want to draw this as a waveform, what it will look like, this side is it is voltage or current, and this side it is time, right? So let's say this is the current waveform, and then this will be the voltage waveform, right? Or let me draw it in a different way. Okay, let me draw it in a yellow color. Okay, so this will be your, let's say, the voltage. Now why it is like this? Because see, we are understanding, so this is 5 in this scale, so voltage is 10, so it is almost double, so this should be voltage. But look at it, the most important thing is that since the current this load is completely resistive, so we understand, we are assuming that this is a pure resistance. Okay, so we understand that this is a pure resistance. That is why there is no phase difference. So both voltage and current starts from the same place and it becomes zero in the same position. No, now if we want to draw a phasor diagram of this, how it will look like. So I think we all know that this portion, this is 180-degree. That is how it is represented, and again this portion is another 180-degree. So this is constitute this total 360-degree. This portion is 90, this is 90, this is 90, again this is 90. Now if I draw this as, let's say, I'm drawing this as 0, this is the 0, means this is 0, this is 90-degree, this is 180-degree, and this is 360-degree. So that is what I'm going to draw. Then what would be the voltage phasor? What would be the voltage phasor? Voltage phasor will be something like this, double of it, right? So it means current and voltage are in the same phase. So this is what we call current and voltage, both are in the same phase. So it can also be drawn in a different way like this. So this is voltage phasor. Let me draw it here. No? uh, this is voltage phasor, then this is current phasor for a resistive circuit. It's a pure resistive circuit. Now let us see what is the case in case of when a circuit is not only resistive, it has some, let's say there is some resistance and there is some inductor into it. Okay, and the voltage is supplied here. So let us not enter into this calculation mode. So in this case, it will be impedance. Impedance is equal to R plus. Now it will be written as JXL. I'll come to a separate video about what is J and why it is coming here. But the main theme that I want to say is that where if we draw the voltage and current waveform, it will be something like this. Let's say if this is the voltage waveform, if this is the voltage waveform, then the current waveform will start somewhere delayed, something like this, maybe something like this. So it will be something like this. So you can see there is a gap, right? There is a gap in this. There is a gap, so there is a delay, right? So if we draw the phasor diagram, how it will look like? It will look like something like this. So let's say again, let me take the voltage as yellow color. So if this is the voltage, then the current will be indicated as like this. So there is a gap, there is a gap, this there is an angle. This angle is called theta, and it is represented as cos theta. This cos theta is called power factor, cos theta, or it also called as cos phi. Both are same thing. So this is called power factor, this is called power factor, power factor. So why it is so? Because now current has two component. One is I sine phi or theta, and another part which is let's say this is x axis, this is y axis. So another part which is I cos phi on that side. So if I want to get the power, what would be the power here? So in case of simple resistive circuit, so power will be V equal to I into R. Uh, sorry, power equal to V into I. Right? There is no other component of it. But here, what will happen? The power is defined as S equal to P plus J Q. So Here P is called the active power and Q is called the reactive power. Now P is defined as V into I into cos phi plus, so it means I cos phi, this component, into V. So it is representing this part that is the active part, and there is reactive part. So this part, this is the reactive part. So this reactive part would be how much is V I sin phi, right? So total power, how it will be looking like? Total power, that is called, also called apparent power. I'll come to that later on. Apparent power is V I cos phi plus j V I sin phi. Now, with this understanding, uh, let me show you very quickly what is power diagram. So, power diagram is called, this is a power diagram or power triangle. Let's say this is called kilowatt and this is called kVA, and it will have a component of this component. This is called kVAR. That is called power triangle, and this angle is phi or theta, whatever. Now, there is one more thing which is called, like, this is Z, this is R, and this is XL, and again this is phi. So what will happen if we write cos phi?